Welcome to Voice Bootcamp, a global name in unified communication. Hi, my name is Faisal Khan, Cisco Voice Instructor at Voice Bootcamp. In this particular chapter, I'm going to focus on router and a logger and their setup. A central controller is when a router and a logger and optionally network interface controller working together. Typically, in a central controller, you'll have a two type of network, a visible network and a private network. Network interface controller, which is a special configuration that allows the router to communicate with the carrier using an SS7 signaling protocol. Now, the private network here, for example, between the router and a logger, is used to communicate, provide for synchronization between these two devices. Also, to detect failure. A router is one of the most important part of the ICM. It is the brain of ICM. It makes routing decision of how to route a call. It also runs routing and admin scripts. It's often referred as a router. You can call it a call router as well. Router, one of the main job of the router is to populate the real-time reporting feeds back to the administration and data server. A call router software runs in a synchronized execution fashion. That means a router on side A and side B will both run the same memory image of the current state. It also passes the state information back between the servers so that information can be kept up to date. Logger, on the other hand, is a database server that stores contact center configuration and temporarily stores historical reporting data for distribution to the data server. A logger receives data from their local router process to store it in the system database. Logger data is also synchronized over the private network. Now, if one of the logger goes down and has been down for more than 12 hours, often you may need to do a manual update, and the manual update can be done by running the ICM DBA utilities. In a high availability environment, Cisco recommends that you design your central controller in a redundant fashion. That means you will have side A and side B. In a side A, you will have a logger A and a logger B, and in side B, you will have logger B and side B, router B. Both of the router from each side or logger from each side will communicate with each other over the private network. So, regardless of your infrastructure geographical location, if you have a side A in USA and side B in India, you have to have a private network between these servers so that they can communicate and synchronize their information. If router A receives a request from carrier, router A will also ensure that the router B also execute the same request, so that in case if router A goes down, the router B will continue to provide the service. A call router and a logger will be deployed in this fashion, where you have side A and side B. Side B will be acting as backup. This type of environment or deployment is known as duplex mode. If one side goes down, other side continue to function in a continue to operation in a simplex mode. We'll talk about that shortly. When you have a physical machine running both call router and a logger, that machine is known as Rogger. Now, Rogger is usually a central controller which is not geographically distributed. It is recommended that both of these two servers are close proximity to each other. Now, if they are in the same room or maybe same data center, then you can probably connect them over the private network can be connected using just a crossover cable. When you have a central controller on a physical machine with call router, logger, and a peripheral gateway, that machine is known as Progger. Again, not designed for geographically distributed environment. In a duplex mode, networking infrastructure becomes a vital because duplex servers will communicate with each other to synchronize their database over the private network. So it is a network infrastructure in ICM composed of a public network and a private network. If a 5 sequential heartbeat between these servers are missed, where each heartbeat is about 100 milliseconds, then the failover process will start. Now of course the failover mechanism will depend on various other aspects of the configuration. In a private network, you have to make sure that only ICM traffic is passing through those network to ensure that nothing can cause delay in the network or packet drop. It is very, very important that you have an isolated private network that is not used by anybody else. To create the router and a logger, the first thing we need to do is create an instance using a web setup tool. Now you must define the instance in a domain manager first before you log into this web page. But once you do that, you log into the web page and then select the facility and the instance that was defined using the domain manager. Now to set up a duplex router, the first thing you need to do, define what site this device is. So Cisco recommend that you first set up site A completely before site B is installed. In the fault tolerance, we're going to select duplex. At any given time, you can go from duplex to simplex, which makes life much easier, or you can go from simplex to duplex by configuring additional network interface cards. If you are deploying Contact Center Enterprise in a hosted solution, then you may need remote network routing. But in this case, we're deploying it for enterprise, so we don't need to select this particular option. Now the router connectivity, like I said, private network will be used for the router to synchronize and detect failure. Visible network on the other hand will be used to communicate with the client and other devices. So in this scenario, you're going to define a private network interface card. In each router you will have a visible and a private network. Now you may have an additional network in a private for high priority traffic and normal priority traffic. So typically what's the proper design is, you will have router A and router B. Router A and router B will have two physical network cards which will be marked as private normal and private high. So both of these network cards will be local private area network or private network. Now the high priority traffic, such as traffic with DHCP value of expedited forwarding, will go across the high priority network, whereas the normal traffic will go through normal priority. So for each router you must have both high and normal interface. Now basically what it is, this could be just a host name mapping to a particular IP address on the other site or the site itself. Now for public interface is usually the visible interface, the name of the visible interface that you have. The next step of setting up a router is to define how many peripheral gateway this router will support. Now by selecting this particular field, it is very important that you understand how the peripherals are identified. When you put the when you enter 1-4, basically you're telling the router that you are going to enable PG1, 2, 3 and PG4. So if I try to configure PG5, the router will not allow me to configure PG5. Well, it will allow me to configure it, but it will not communicate properly. So if I want PG5, then I have to rerun this setup and make sure I increase it from 1-4 to 1-5. If I put a range which says 1,4-7, that means I'm enabling PG1, PG4 to 7. PG2 and 3 are not supported. If I just put 10, that means only PG10 is enabled. So if I put PG10 here, for example, and try to configure PG1, I'm going to get an error message saying unconfigured DMP ID. Now if I want my routing script to communicate with an external database, I must make sure that the enabled database is checked. If I want my external script to communicate with external application, then I must ensure that application gateway is also enabled. For QoS, I will enable QoS right here. Now if I face a problem, if the router faces a problem for whatever reason, you don't want the machine to reboot, then simply select reboot machine on error, make sure it's unchecked. When you enable QoS, you can define what the QoS settings will be on the private network. Now you can click on start and stop and then start the cycle. If the router already exists, then click on finish. Now if you are RDPing to the server, you may not see all the process the router is using. So to see all the process on application that are activated, when you RDP in, make sure you put the command for a switch called console or admin. Typically RDP is a session, so the router will not display any of those processes that are running in the desktop. Now here's an example of a router process on site A. In site A, you have a central controller is available when you see the router A CC agent. Now router A router will show me that DB process on site A is up, DB process on site B is also up. This also tells me that the site A RTC process is okay, and various other settings, whether there are any problem or not. Application gateway configurations delivered, for example. On site B, you'll have a similar settings. As you can see, central controller is service is available. Both database seems to be okay and processes are running. Now, once the router part is done, the next step is to add a logger. Now, in order to add a logger from the web interface, the first thing you need to do is run ICMDB. ICMDB is a utility that allows you to create database for various applications, such as the logger. You need to add a logger database. You need an administration and data server database, and optionally historical data server as well. If you're going to use an outbound dialing option, then you need an outbound database. Now on site A, you will have logger database, administration and data server, and optionally outbound database. But on the site B, you'll have logger database for site B, that's a typo by the way, logger A, and administration and data server. On site B, there is no outbound database. You can take a look at our lab guide for Contact Center Enterprise to see how ICMDBA will be used to create databases. So at the end of the day, in a duplex settings, you will have similar outlook. You will have site A and site B with the necessary databases as well as servers. Once the ICMDB is completed, the next step is to go back to the web interface and add a logger. So similar settings, define the instance. Deployment type will be enterprise because we are deploying an enterprise contact center enterprise solution. Site will be site A. Fault tolerance will be duplex or simplex. So if you are going to do redundancy, make sure you select duplex. Now just because you're selecting duplex and site B doesn't exist does not mean site A will not function. It might give you a lot of errors, but it's going to continue to function properly. Now here you define the private interface for the both logger to communicate with each other, along with the router interfaces as well. You can enable DB replication and purge configuration setups. The DB purge configuration steps allows you to change some of the timers or parameters for DB purging. If you are going to enable outbound, make sure you select this, and this option is only can be enabled on site A router. Now I keep saying site, is actually site. Now again, troubleshooting option, reboot error, reboot on request. Make sure you uncheck those options. Logger database will have similar process. Again, if you do not see this process and the service is running, most likely it is due to the fact that you're RDP into the box without those two switch, console or admin. Now here is telling you that it is connecting to particular database, for example, on certain port, and these are some of the stuff that you can use to troubleshoot to see whether the connectivity is successful or not. In a duplex mode, fault tolerance becomes a vital. A redundant configuration is often known as duplex mode. A non-redundant configuration is often known as simplex. Simplex is not supported in production. The two sides of redundant deployment are referred as site A and site B. The both side is running normal. It is known as duplex mode. When one side is running, it is running in simplex mode only. Now the two sides are for redundancy, not for load balancing. If one side goes down, the other side will handle the calls, but not both sides will not handle the calls simultaneously. Side A and B are both executing the same set of message and therefore producing the same result, so that in case one side A goes down, side B will know exactly what to do with that call. A call router will run synchronized execution across the two servers, which means both sides of the duplex servers process every call. In the event of a failure, the surviving call router will pick up the call midstream and continue to process real time without user intervention. A failover process is very complex in contact center enterprise. A survivable server, such as side B, will detect that there's a failure after 5 consecutive TCP keep alive message gone missing. A call router will generate this TCP keep alive every 100 milliseconds, so it takes up to 500 milliseconds to detect a failure. Now, when a side B router detects a network failure because of the private network outage, maybe, for example, what it does, it uses a visible network to communicate with the PG, and the peripheral gateway will verify if there is a type of failure. Now, if the failure is a network outage, the both router can continue to function even if they cannot communicate with each other over the private network. The condition is that the PG continues to see both router since they are on the visible network. The router B will talk to the majority of the PG to see if the router A is up. Now, the way it does so, the router B will send something called test other side, or TOS message. If the router A is in fact enabled, the router A runs in is going to run in a simplex mode, and the private until the private local area network is restored. Now, if all PGs send TOS message stating that router A is in fact disabled or down, then the router B will reinitialize and operate as simplex mode and start taking over the calls. Now, that is the private network failure. But what if the router itself fails, the server crash or the process crash? In that case, if the service or the hardware fails, the PG will report that it is unable to communicate with the router. The router B will then take over in a simplex mode. A failure is detected due to the loss of heartbeat in a private network. Now, during the call router failure process, an existing request will be queued until router is in active status. Any call in the progress will not be impacted because the router B will take over the call. And since the router B already have information about that existing call, remember, they are executing simultaneously, the router B will be able to process without having any impact on that call. Now, if the logger or AWDB fails, then there is no immediate impact. But the local router will not be able to store data if the logger fails. Now, if logger X, for example, is restored, is determined how long it was off. If it was off more than 12 hours, less than 12 hours, then an update request will come from the redundant server. But if the server has been down for more than 12 hours, then the manual synchronization is required using the ICMDB utility. The historical data server on AW server will stop if the logger fails. So if the logger A goes down, all outbound option also stops as well, since the outbound option is only available on logger A. So here's an example. For example, in this scenario, the private network between the side A and side B goes down. Side A continue to run in a simplex mode. PG, side B will send a TOS message to PG, test other side. PG, which already knows the side A is still active, will notify side B that, hey, side B is active, so side B will not take over the call. Side A continue to function as if the primary call, active call, contact center enterprise. On the second scenario, on the right hand side, side A goes down, the server itself or the process. In that case, the communication between the PG and side A is broken. When side B send a TOS message to the PG, PG will say tell the report to the side B saying side A is inactive. Therefore, side B will then take over the call and becomes a simplex mode contact center enterprise. So this is basically how the router will provide failover in a fault tolerance environment.